Hey everyone, here's another example from section 3.1. In this case, they're going to ask us to find the minimum y value on the graph of y equals f of x. So they give us an equation that's in standard form, and they want to find the minimum y value. So they're asking for a minimum point. Well, if you remember the minimum point on a graph, if you look at this leading coefficient, our leading coefficient is greater than 1. So if you have a greater than 0, you're going to have a minimum value. But if a were to be less than 0, you'd have a maximum value. And you know this because if if you have a number that's greater than 0, you're going to have a parabola that opens upwards. And if you have a value for a less than 0, so that would be negative, you would have a parabola that opens downwards. So you'd have a max here, and in this one you'd have a min. So really what they're wanting to know is they want to know what's the bottom point. What's the bottom point for this function here? So if I put this in vertex form, I could find the vertex, and the vertex would be this bottom point, which is the minimum. So really when they ask, find the minimum y value on the graph of y equals f of x, they're really asking for you to find the vertex for the function. And you just have to determine whether or not you have a function that opens up or opens down. And then if you put that in vertex form, you'd know the vertex. But that seems like a lot of work. So there's this formula for the vertex. So we can find the vertex. So find the vertex of a standard form quadratic. So we can find the vertex of a standard form quadratic by knowing its coordinate is going to be, so there's this little equation, negative b over 2a. And then to find the other part, we say that we're going to take the function of negative b over 2a. So I know you guys remember this from Algebra 2, or at least have seen it, but if you want to find the vertex of this standard form equation, you use this formula for the coordinates where you have negative b over 2a. So you take the negative of the b value and you divide it by 2 times the a value. So let's kind of take a look and see what that looks like. So if I start with negative b over 2a, that's going to give me negative 9 all over 2 times 9. Now remember, we have 9 in each of these, but this 9 comes from this term, this 9 comes from that term. That's going to give us negative 9 over 18, which gives negative 1/2. So negative 1/2 is my x value for this function. So I'm going to write that right down here. Let's give myself a little bit more room. And I'm going to write down here at the bottom, this would be negative 1/2. And now I'm going to evaluate, I screwed that up. Let's go negative 1/2, comma. Now let's evaluate this function for negative 1/2. So we're going to say of negative b over 2a, well that was negative 1/2. So we're going to say function of negative 1/2. What's that going to give us? Well, that's going to give us 9 negative 1/2 squared plus 9 times negative 1/2 minus 1. So that's going to give 9 times 1/4 plus 9, or negative, I should multiply that. So that should be not plus, that should be minus 9 over 2, because 9 times negative 1/2 is 9 over 2, minus 1. So that's really going to give 9 over 4 minus 9 over 2 minus 1, which we can find common denominators for all these. So it's 9 over 4 minus 18 over 4, and then minus 4 over 4, which is going to give 9 minus 18 is negative 9, minus 4 is negative 13 over 4. So that's going to be my other coordinate. And this is the minimum value. So my minimum value, and remember it says, if you look at the very beginning, it says find the minimum y value. So the minimum value would be, y value would be this right here, which is negative 13 over 4.